12 by 220. My table is a bit different from the table of the book, but it's on really the same lines actually. Okay. You can make a matrix out of it. Okay, so what is first? 1 over 220. In other words, choosing all 3 red balls and no white ball actually. So it's going to be 3 choose 3 divided by 12 choose 3. So obviously this makes sense. And then 0 and 0 and what do we call 0. Okay. So now, what does, okay, so I would like to give you now, does these probability distributions satisfy what you have, for example, here. So what was the first property, for example, that you have for the joint PDF? The joint for the first property of the joint PDF was that all of the f of x, y should be between 0 and 1, so they are indeed between 0 and 1. And the sum of the probabilities, okay, sum of the all probabilities, all possible probabilities should be equal to 1. So what you can do is that if you sum up all of these probabilities, okay, if you sum up all of these probabilities, you're going to call these probabilities as, or you're going to see that these probabilities are, their sum is equal to 1 actually. Okay, so their sum is equal to 1. So this is really the probability distribution for the joint of x and y, or for the random vector x and y, where the first component is random variable x and y, random variable what you call y. Now question, where are the marginal distributions actually? So if I want to have what you call the marginal distribution, so in order to marginal PDFs, in order to have the marginal PDF, what you need to do, you need to sum up the rows and the columns actually. So if you sum up rows and the column, for example, if you sum all these, so this is like summing this sum can be treated as what? This sum can be treated as probability of x equal to 0. And what do you mean by the probability of x equal to 0? The probability of x equal to 0 means that y can be 0, can be 1, can be 2, can be 3. So if you sum up all these, you're going to get what you call 84 by 220. And what does this represent? So this is the probability of x equal to 1. And so when x is 1, y can be what? Y can be 0, y can be 1, y can be 2, y can be 3. You sum up all these probabilities, and what you're going to get is 108 by 220. Okay? And this is really the probability of x equal to 2. Okay? And x equal to 2 is really the 27 by 220. And this is probability of x equal to 3. And this probability is equal to 1 by what do you call 220. Okay? And if you combine these probabilities together, I mean if you want to name this vector of the probabilities, so this is the marginal PDF probability density function of the random variable x. So this is the marginal PDF of the random variable, what do you call, x. And this is really PDF actually. The marginal PDF of the random variable must be a PDF, because if you sum all these probabilities, the sum of the probabilities should give you 1 actually. So it's indeed a PDF of X. Okay? But you are extracting this from the joint PDF. And similarly, if you take, for example, the row sum, you're going to get the marginal PDF of what do you call Y. Okay? And that PDF is indeed going to be a PDF. Okay? So I hope it is making sense to you that if you have the joint of the PDF, you try to compute the probabilities for the different, what do you call, you get the probabilities, you try to write the probabilities in the terms of a matrix set, where each entry of this matrix or the table is representing the joint probabilities, okay, for the random variable taking, you know, different values. So I hope this is a little bit making sense to you actually. So here is another example. So we will try to make another table of it, and then, you know, we will move on to a bit more sophisticated stuff. So imagine, so this example goes like this. Imagine that the 15% of the families in a certain community, so imagine you have a country or a community or a place or a region, and in this region there are 15% of the families that have no children. Okay, so the 15% have no children. Okay, so in this community, the 20% have one child, have one child, 35% have two child, two children. Okay, and 30% have 3 children. Okay. So with this information, I'm interested in 2 random variables. So imagine I am choosing a family at a random out of all of this community, and B represents the number of boys in that family. Baby boys are the boy children in that family. Boys in family, and G represents the number of girls in family. Then what values B can take? So a family has at most 3 children, so you can have a family in which there is no boy, okay, and there is one boy, they can be 1 boy, 2 boys, or at most all 3 boys actually. And similarly for the girls, you can have 0, 1, and 2, and 3. Okay? And I am interested in writing a table for the joint of the boy and girl actually. Okay, so for the what would be the probability distribution for boys and girls actually in a given family. By the way, in a family, what could be, so you know, so it's like if B is taking these values and G is taking these values, what could be the possible values that this ordered pair or this vector can take? So it can take 0, 0, okay? So it can take 0, 0, it can take 0, 1, it can take 0, 2, and so on and so forth. It's going to take 2, 1, it's going to take also 3, 3, and so on and so forth. But what would be the interpretation of 0, 0? So in a family, there are no boy and no girl actually. So therefore means that there is no kid. There is no boy and one girl, no boy and two girls, two boys or one girl, there are three boys and three girls. So this is an impossible event actually. So this must be an impossible event because in this community the number of children are at most 3. So you can't have 3. In other words, 3 boys and 3 girls actually. So this is not going to happen. So what I would like to do, is to write a joint PDF for boys and girls. So let's make a matrix or maybe a table actually. Okay. So if in that I say that B takes the value small b and G takes the value small g. Okay. Then this small b can be 0, 1, 2 and say 3. G can be 0, 1, 2 and 0, 1, 2 and 3. These are the values that it can take. So what is the first component actually? So in other words, what is the probability? So it's like the first component is like f of 0, 0. Obviously f depends on b and g, you can write it. F of 0, 0 means what is the probability that a randomly chosen family has no boy and no kid actually. You can extract this information from here. Okay? You can extract this information from here. So it's 15% actually. It's really what you call 15% R. So it's really the 0.15. Okay? Now, what would be the meaning of, say, for example, F01? Okay? So F01 means what is the probability that that in a given in a given family or in a chosen family there is no boy and there is one girl actually. So you're going to have the case that, okay, so you have the case that, so you're going to say that one boy, one girl and no boy. By the way, so this is going to be the part of these families actually. So you are talking about the scenario where the families have one child and the child can have a chance of 50% chance of being boy and 50% chance of being girl if you choose it randomly. So you're going to say that, okay, so it's 20%. So it's 20%, okay, it's 0.2 of probability of having one child. But what is the probability of that child being a girl? So that child being a girl is 1/2 actually. So this probability should be 0.1 actually. Okay, so this should be 0.1. What is the probability of say F02? In other words, okay, so I'm doing something really silly. Okay, so this is 0, 0. Should be 0, 1 actually. This should not be 0, 0 because the first component is for the boy and the second component is for the girl actually. So if it is 0, 1, so it should be written here actually. So the 0 girl, no, 1 girl and 0 boy, so it's going to be 0.1 actually here. Okay. Now what would be, for example, f of 1, 2? Okay, let's imagine I want to compute this. So what is the probability that you have randomly chosen a family in which there is 1 boy and 2 girls? So this is going to be from the situation Okay, and how many families are there? So there are 30% probability. So it's going to be what you call 0.3. But what is the probability of having one boy and two girls? So it's going to be 1/2 for having one boy, and two girls is going to be 1/2 square actually. So you can have this number, and that number is going to be what you call come here. So F1 and 2. So F1, 2. So this is the entry that is going to be come here actually. So what you have to do, you have to complete this table. Okay, and in exercises you will be given, you have to face what you call some of the interesting questions regarding such kind of the probabilities, where you have what do you call such probabilities, okay, and you have to find the events actually. For example, if I say that what is the probability of, if I ask from you, for example, that what is the probability that boy is greater than 1 and the number of boys is greater than 1 and number of girls are greater than, what do you call, less than 1 actually. So this probability can be computed through this table actually. So that if the boys are more than 1, that means that the boy can be 2 and girls are less than 1, so it should be 0. And the boy can also be, what do you call, 3 and it should be 0. So you have to take these two probabilities to compute this event. Okay? You can also have a situation where for example, I can say, okay, what is the probability, what would be the probability of the event when, say, the boy is less than 2 and girl is bigger than 1 actually. So you have to choose appropriately all the possible outcomes actually. So in other words, the boy can be 1, okay, and girls can be 2. Boy can be, for example, 0 and girls can be 2. This is also another possibility. The boys can be 0, okay, and the girls can be what we call 3. So these are the three possibilities, three probabilities. I'm sure that you can have, that you need 3 numbers to add them up to come up with what you call this simple probability actually. Okay, so you need to solve such kind of questions when you are trying to deal with the situation. So overall, while you are dealing with the two discrete random variables, you have to always take care of such kind of tables, and the most of information that will be extracted is going to be from such kind of tables actually. And you should need to know that, okay, if you have been given the tables, how to find the marginal PDF of one of the random variables, and how to check that the joint PDF is indeed a PDF, and how to compute the different kind of events using the given table actually. Okay, so I hope that it making a little bit sense to you. Next, I would like to move to the what do you call the joint PDF, joint distribution function. Okay, joint distribution function, or maybe the joint continuous time distribution function. So instead of discrete, now you have two continuous random variables and you want to compute their PDFs and the probabilities corresponding to it. So how to deal with that kind of situation actually. Okay. the continuous time joint of two continuous random variables. Joint of continuous random variable. Okay. By the way, it would be very interesting to think that, okay, so for the two random variables you have this matrix, for the two discrete random variables you have this matrix actually here at the table. The question is, if you want to make a similar kind of a table for, say for example, three random variables actually, or the joint of three random variables, how does it going to look like? So that is no more going to be a matrix, but it is going to be a tensor actually. Okay, it's going to be a three-dimensional vector. It's going to be a box of numbers, not the numbers in plane. We can talk about it in our Zoom session. I mean, if you have any questions. Okay. So, how to do it? Say let C be a collection of the points let C be any pair of random variables, be any pair of real numbers. So imagine that it's an ordered pair xy. Okay. But now the random variables are being chooses from R to R and they are continuous actually. Then what is the probability? Maybe you can say, maybe the best is to say that let C is a subset of R cross R actually. Okay. So what would be the meaning of subset of R cross R? For example, a rectangle is a subset of R cross R. A circle is a subset of R cross R. So, I mean, if you take the two-dimensional plane and take any closed region, take any region, okay, or even a curve is a subset of R cross R. So, all of these are the subsets of R cross R actually. Okay. So, imagine C is a subset of R cross R, and I want to compute what is the probability, that the ordered pair or the vector xy belongs to this region C actually. In other words, you take this region in R2, okay, and xy is any point in this region actually. So what is the probability of happening this? So how are you going to write this probability? So the answer is that we're going to do the same as we did in case of the one-dimensional random variable, or one random variable, one continuous time random variable. So it was an integral actually, but that was an integral in R, okay, or over an interval R actually, or subinterval of R. Now it's going to be the integral over the region, so it's going to be a double integral actually. Okay, the double integral. So you're going to say that you can compute the probabilities, such probabilities that when x and y are in a region of R, as that, okay, you integrate the joint PDF, okay, of x and y, okay, and compute the double integral over the entire, what do you call, region C actually, okay, over the entire region C, where fxy of xy is a joint continuous time PDF of x and y. You can also call it that it's a PDF of the vector x and y. Okay, it's a PDF of a vector x and y. So saying that this is a PDF of x and y, joint of x and y is same as that it's a PDF of the vector x and y. Okay, and what would be the basic properties of such kind of PDF is that obviously all of the values that this PDF takes should be between 0 and 1, and the double integral of the probabilities x and y dx dy, where x can take what value? So the x is a continuous time random variable, so it can take any value over the interval r. Okay, so this x is from minus infinity to infinity. This is also from the minus infinity to infinity. Okay, so if you integrate the f of x y from minus infinity to infinity with respect to x and with respect to y, it should give you 1. So if you have such kind of a function that satisfies two properties, then you can use that function, then you call that function as the joint PDF, continuous time joint PDF of x and y, or the PDF of the random vector x and y. And using that PDF, you can compute what is the probability that your random point, a random tuple, a random vector is in what do you call random ordered pair is in the region C. And how you're going to compute it? So just simply integrate you call your PDF in the region C actually. Okay, just compute its values actually. So to be more concrete, if I say that imagine C is like A cross B. Okay, C is the cross product of what do you call two dimension. Any region in two dimension can be seen as a cross product of what do you call two lines actually, are two sets A and B, where A and B are two subsets of R. So take the two subsets of R and take their cross product and give it a name C, and then when I'm saying that what is the probability that xy belongs to C, means that what is the probability that x belongs to the set A and y belongs to what you call set B. And in this case, you can write this integral even more explicitly. So what you can do, that okay, compute the double integral, okay, compute the double integral of the joint of the PDF over the interval, say over the set A with respect to x first, and then with respect to what do you call B first and B afterwards. Okay, so that's how you can also compute the values. For example, you can have a situation where your C region is a rectangle actually. So in other words, C A is an interval, say A to B, and B is an interval C to D. Okay, then C is this rectangle A to B cross C to D. You can see this in two dimension actually. So you can say that okay, my A is here